Yesterday we explored some similar polygons, mostly triangles, but we had some rectangles in there. Today we want to talk about that exploration a little bit. So if you were working, if you did your job well, you found that we had sides that looked like this. And if you found it to 2 decimal places, you had sides that look like that. Okay, so check your work. Now, those of you who did the opposite side, you had the similar experience. So we're going to talk about all of this. But some of you did the opposite side, the back side of the exploration, the GeoGebra activity instead. A couple people did. A couple people did. Okay. Okay. We had some trouble with it, but that's okay. So 2.24, 1.12, and then we ended up with a 9, 12, and 15, and a 3, 4, and 5. If you notice that these went by 2s. Yeah, the scale was 2s. Okay. So when we look at this first one, did we scale it up or down? Up by a scale factor of how much? 2. This is 2 times as big for all of the sides. The sides are in proportion. The second one, did we scale it up or down? By a scale factor of what? And this third one, scaled up or down? By a scale factor of 3. 3 times as big for all the sides. Okay? What happened with perimeters then was we ended up with a perimeter of 7.16 and 14.32 here. Is this twice as big as this? Yes. Okay. Perimeter of 6.48 and a perimeter of 3.24. Is this half as big as that? Yes. Needed to do it to 2 decimal places. Okay. Okay. When you're finding your square roots using distance formula or the Pythagorean theorem, use it in your calculator. Okay. Okay. Fill out your planner. Last example then, we had a value of 12 and 36. 3 times as big, correct? Okay. Here's where it's interesting. Okay. When we find the area, half the base times the height, or base times height divided by 2. You're fine. Okay, to 2 decimal places is what I was asking for. Okay. All right, when we work on these area problems, what's unique about this is this area came out to 1.5 and this one was 6. Is that twice as big? It's 4 times as big. And this one became 2 and 0.5. Is that half as big? It's a fourth as big. This one had areas of 6 and 54. Is that 3 times as big? 9 times as big. Okay, so here's what's odd about areas. Okay, it's not the same scale factor. What would I have to do to 2 to make it 4? Times it by 2. Okay, what do I have to do to take, what do I have to do to 1/2 to get it to 1/4? Divide by 2 or times it by a half, right? And what would I have to do to 3 to make 9? Multiply by 3, right? 3 times 3 gets me 9, okay? So what happens here is we take our scale factor and we're squaring it. Scale factor squared. Scale factor squared. Scale factor squared. Okay, so that's what I was hoping that you learned from this yesterday. The areas. Okay, to find the area of triangle ABC in this first example, it says to take the base times the height and divide by 2. So 1 times 3 divided by 2 is 3 divided by 2, which is 1.5, 1.5. Okay. Base times height divided by 2. 2 times 6 is 12. Divided by 2 gives me 6. Right, and remember I told you to change that formula. I copied it wrong. I was copying and pasting an equation editor. Okay. Okay. We're not doing the other side today. So you're going to pass this forward. And we're going to talk about proportions. That's okay. I was just wanting to get to that piece of it. Okay? So, okay. So pass them forward. And while you're passing them forward, we're going to talk about proportions. If you want that first seat is fine. There you go. Now let's start with fill out your formulas, and then when you're done, turn that in and you can get the real ones. I have some on the wall. Okay? All right. So here we go. It's the same kind of thing. Okay, anybody? No? All right, so here we go. We're going to talk about corresponding parts of similar polygons. Okay? In the past, we talked about corresponding parts of congruent triangles, right? Now it's corresponding parts of similar triangles. And we have a new symbol. Triangle ABC is similar to triangle DEF. Here's our new symbol. It looks like the congruent sign, but what's it missing? The equal sign. So it's not congruent. That was congruent. This is similar. Okay? Remember back in chapter 4, we talked about how we transformed figures. We did translations, which preserve the size and shape, rotations, which preserve the size and shape, and reflections, which preserve the size and shape. But now we're talking about dilations, making it larger or smaller, scaling it up or down. So it will preserve the size, or the shape, but not the size. Okay? Angle measures will be preserved. The size will not. Okay? They will be in proportion. So you have to watch for these angle measures in your drawings. A is congruent to D, which you can also get from here, because when they said ABC is similar to triangle DEF, they listed A first. That means A and D are congruent. It's up to you how much you want to write. I'm also going to have it posted. Okay. Likewise, B is congruent to E. Angle B and E are listed second that means that B and E will be congruent to each other. And they will have corresponding tick marks, 2 tick marks, 2 arcs. And finally, C and F are angles that are congruent. So C has 3 arcs, F has 3 arcs, and they are listed last in our statement. Yes. Triangles, when we're talking about triangles with a scale factor of 1, or angles themselves. Okay? But when we're talking about the sides, they have to be in proportion. They're not going to be congruent anymore. Okay? Unless the scale factor is 1. Okay? So here's a good example of that. We're scaling from this triangle to this triangle, right? Is that scaling up or down? Up, making it bigger. Okay? That means that we want to make sure that the one we're going to is over here listed first. Because my scale factor, is it going to be bigger than 1 or smaller than 1? When I scale up, is it going to have a scale factor bigger than 1 or smaller than 1? Bigger than 1. Okay? That means that we want to have the sides of the bigger triangle in the numerators of our fractions. Denominators have the smaller triangles. Okay? So far, so good? Okay. So let's look at an example and see how you can, the things they can ask us to do. Okay? In this diagram, triangle ABC is, what does that symbol mean again? Similar to triangle JKL. So first they want to know what's the scale factor. So when we went from ABC to JKL, did we scale up or down? Up. So we want to make sure that we have our sides, our larger sides on top. Okay? Then we say, what's the scale factor? So Nolan, pick a side on JKL. Which one do you want to work with? 48. Okay? If you say 48, then you have to use the appropriate side of your other triangle. Aaron, which one corresponds to 48 on our smaller triangle? 36. Then, to find our scale factor, we have to simplify it. Simplest terms, reduce. You could divide by 3, but we wouldn't be done. Okay? Okay? So 12 is our greatest common factor here, isn't it? 48 divided by 12 is? And 36 divided by 12? 3. So we have a scale factor of 4/3. Okay? Now it didn't matter that Nolan chose to start with 48. Nope, because if you had chosen 28 and put it over 21, it would reduce to 4/3. And if you had chosen 36 and put it over 27, it would reduce to 4/3. But you have to make sure you're using the corresponding parts of those triangles. Can't mix them up. So when he chose 48, KL, that means he had to go and get BC. Does that make sense to everyone? So the math is not hard. We just have to choose correctly. Choose wisely. Okay? Okay, so where did I lose you? I'm sorry. Okay, so we said that we're wanting to find a scale factor. So we want to see a ratio of the sides. How much did we expand this? How much did we make it bigger? Okay, so you start by, there's lots of ways you can start, but you can say, okay, I want to start with AB because AB are the first 2 letters that are listed in that triangle. Okay, then it has to correspond to JK. Okay, then I look and I say, I'm actually scaling up. So I want my bigger number, my number from my bigger triangle to be listed first. Okay, so JK is 36 and AB is 27. The scale factor of this is 36/27. but we want to always reduce it to lowest term so we all have the same scale factor. Okay, so they both have 9 in common. Okay, 36 divided by 9, 27 divided by 9. Okay, so it should always be the same scale factor. It shouldn't matter if you chose AB and JK or BC and KL, or if you choose AC and JL. Okay? Yes. We're going to do that in just a minute. Okay? All right, so far so good? Okay, so map, anytime you're making maps, you scale things up. If you're doing blueprints, obviously we can't have a full life-size blueprint of a house, right, to figure out where to put things. Blueprints use these scale factors as well, and similar polygons. So lots of application in construction. Map reading, map making, those types of things. Okay? The second part says to list all the pairs of congruent angles. We've done this before. Okay? If I said, which one is angle A congruent to? You would say J, the very first one listed. If I said, what is angle B congruent to? K. And finally, what is angle C congruent to? Angle L. And I know that all of you are going to want to skip writing the angle symbols. Don't. Okay? Otherwise, they're points. Points aren't congruent. They have no dimension. So, okay? There's paper towels over there. Okay? Ratio of the corresponding side links. Okay? In a statement of proportionality. Okay? Side links. Now we want to know which side links are corresponding. Okay? You can use those statements again. Okay? So when they want side links, they want you to give us the symbolism. AB and JK. So JK is to AB as KL is to BC as JL is to AC. Okay? That's what they're looking for. All the combinations, making sure that the big triangle is on top and you've got the appropriate corresponding small triangle side links on the bottom. No. We'll throw in some trapezoids and some other quadrilaterals. That would be, yeah, no, we're not going to give you an octagon. Okay? All right, so another example. Here's, yep, give me 1 second. Okay? It's bleach water.
Sure?
Mm-hmm.
No, it smells gross.
Okay, question. It's okay. I'm positive. I'm sorry, which one? Letter A? What about letter A? Okay, so they'll give you a congruence statement, and A is the first one listed, so J has to be the corresponding angle. Okay, or they will give you an angle arc, and they will give you one that corresponds to it in the other figure. Okay, or they will give you a double here with a double here, and a triple here with a triple here. 48, and we could have used that as well. There's nothing wrong with that. As long as we make sure that we have 48 over the appropriate corresponding part. Okay, everybody good? All right, next slide. Now we're asked to find the value of x. To find the value of x, we are looking for KL. Okay? What is, yes, sir?
Okay, so it went up by like half, so I said KL is 18. Right now.
Okay, well, KL corresponds to which one in our other triangle? HM. So KL is to HM as another pair of corresponding parts are to each other. Okay, so we know HK, right? HK is how much? 15. What does it correspond to in our other triangle? GH, because HK are the first two and GH are the first two. So 15 is to 20. Because HK is my 15. Sorry, I wrote the wrong one. HG is what it corresponds to. That should be 10. My apologies. Okay? Everybody good? Okay. Almost. Now what we have to do is we have to cross multiply to solve for x. So when we have x is to 12 as 15 is to 10, that means that we would cross multiply and get 10x equals 12 times 15. So 12 times 15 is what? 180. So if 10x equals 180, x is 18. This is the kind of work I need to see. Proportion set up. Tell me what you're multiplying. Tell me your answer. Yes, sir.
Alright, so basically, it's just like that. But whatever's the opposite of x, like the corresponding,
And then two other corresponding sides. Making sure that you always put the larger triangle on top and the smaller triangle on the bottom, or vice versa. Okay, but you can't start with one, say x is to 12 as 10 is to 15. You have to, whatever you started with in the numerator has to be what you end up with in the numerator on the second proportion. Okay? Yes. Yes. Okay. All right. So what we learned about earlier, the sides were in proportion, the perimeters are in proportion. Okay? Turns out the special segments in a triangle are also in proportion. So medians will be in proportion. Altitudes will be in proportion. Okay? That means that if I'm trying to find the median ST, you can write it as ST or you can put a variable x there. It doesn't matter.
Okay.
Oh, he's got it.
We ready? Okay, we want to be able to find the length of ST. So, do you want your ST to be in the numerator or the denominator? It does not matter as long as we are consistent. Numerator. Okay, so x is going on top. What does it correspond to in this triangle down here? CW, which has a measure of? So, that means we have to come back up here. You can either use the whole side, or since it's bisected, you could use half of the side, 36. Okay, so TR is 36. What corresponds to TR down here?
That's VZ.
VZ, that's 16. Okay, now we cross multiply. 16x And whatever 12 times 36 is, and you can plug that into your calculator.
That's like 1,000-ish number.
Divide by 16. Can you see that you need your calculator?
Yes.
Okay, question. Okay, if QT was 20, still the same process. It has to be a median or something, though, that bisects, or you have to find the appropriate corresponding parts in the other triangle. Absolutely. Yep. As long as you're consistent with your proportions. If your large triangle's on top, large triangle has to be on top in your second fraction. Okay? All right. 2 more quick examples, and I turn you over to your work. Okay? Okay, here we go. Okay? All right, we ready? All right, next slide. All right, so doesn't matter if all of a sudden, no, don't write this down. Okay? I want you to read it, and I want you to find the most important information. Okay? Width of 6 feet, length of 15, length of 35. And what kind of a figure was it? Rectangle. Okay? When you're taking an ACT, you need to be able to quickly pick out those most important details. Okay? So we have a garden. The garden's a rectangle. He wants to enlarge it. He wants it to be similar to the original. Scale factor has to be the same. So he starts with a rectangle that was 16 wide and 15 long. He has a new rectangle that is, we don't know how wide, and 35 feet long. What's our proportion going to say? Good. If you start with the small one, you've got to come back to the small one. Doesn't have to be. You can do it the other way. Okay? It has to be on the appropriate. So if we're starting with 6 and it corresponds to x, then we have to come back and get the 15 to make it correspond to 35. When we mess up and when we don't get the right answer is if we reverse one of these proportions. Okay? As a rule of thumb, it's usually good to say, hey, I'm going to start with my what I'm getting to and divide by what I had to originally. But it doesn't have to be. Okay? You could also, okay, watch up here. This is interesting. You could also say 6 is to 15 as what is to what? X is to 35. As long as you keep your lengths and widths in the same location, you'll get the same result. Okay? All right. And we know how to cross multiply and simplify this, right? Okay, I'm not going to waste your time then. Here's our last example. This we just talked about. So if it makes sense, you don't have to write it down. Okay, but the next example I would. Okay, so we're saying now, guess what? We're not just dealing with triangles. We can use rectangles. We can also use other quadrilaterals. Okay, and when we know the ratio of their corresponding sides, then their areas will be the square of that ratio of those sides. Okay? If I know a side length over a side length, take that scale factor and square it, I know the area over the area. Okay? So let's look at this problem, this example. This is one I write down, so you have an example of how to do it. We have two triangles. They gave us two side lengths, one of each triangle. And they also gave us an area. They want us to find the other area. So this triangle has an area of 75 square meters. Okay. We want to find the other area, the area of the larger triangle. Okay. So how are we writing our proportion? Small to large or large to small? Large to small. All right, so 14 over 10. Okay, because 14 is PQ, 10 is RS, their corresponding parts. How do we reduce that? Divide by 2, they're both even. You also have an ABC button on your calculator that can reduce for you. Okay, I'll show you in just a moment. Okay, they said they wanted to write large to small. So the large side was on the side on the large triangle was 14. The side on the small was 10 that corresponded to it, and we reduced it to 7/5. Nope, nope, nope. Okay, now the 75 was given up here. They said the area of this triangle, all this space in here, is 75 meters squared. Okay, they want to know what is the area of this guy. This says large to small equals 14 to 10, which is 7 to 5. Okay, and Mackenzie, you had a question? Figured out? Okay, now the thing that we have to remember about areas is when we're scaling it, we take the scale factor and we square it. Not 10. Yes, we have to square the 7. 7 times 7. 5 times 5.
25.
So 49/25 is the scale factor for the areas. And then you're going to set that equal to the other. Now, 75 corresponds to big or small triangle? The smaller triangle, so we have to make sure that it's down here with this 25. Okay? Now we're ready to cross multiply and simplify. And you're all okay with that, know how to do that, right? Okay. Okay. So we cross multiply and simplify. Okay, Megan, what's the problem? What's wrong? Decide what's going on. Okay. We're good. I'll keep moving. Okay? So we're going to skip this one, and this is your assignment. Okay? Let me stop the recording.